Hello everyone. So in this video we will find the initial condition of different RLC circuits. So first we will do that, then we will see the sourced RLC circuits series and in parallel. Okay. So initially what happened in case of inductor that you already know. What do? We either replace it with initial current, or if the initial current is 0, that means we will replace it with open circuit. In case of capacitor, what we will do? We either replace it with the initial voltage, and if initial voltage is 0, we will replace it with a short circuit. At steady state, inductor will be replaced with short circuit and capacitor will be replaced with open circuit. We know all these things, right? We already know. Now this is the question. The switch is being opened at t equals to 0. That means it was closed for t less than 0. Then you need to find these many values. So circuit for t less than 0. I will make the circuit for t less than 0. Circuit for t less than 0. Here steady state would have been reached, right? Steady state would have been reached. So basically I will make the, because I am not interested in the value for t less than 0. I am interested in value for t 0 plus. So I will just make the circuit at t equals to 0 minus. So what will be the condition? This will be shorted and capacitor will be open circuited, right? So a 12 volt battery I have with 4 ohm resistance. This is the inductor which is shorted. Inductor which is shorted. There is this resistance connected and there is this capacitor which is open circuited, right? So this is what is happening. The value of resistance is 2 ohm. 2 ohm. So what do you think? What is IL0 minus? This current. That is 12 by 6, 2 ampere. If you have enough practice, I don't think you will need to make the circuit, but just I am explaining this, all this. That's why I am making it. So what will be VC0 minus or V0 minus? You can say V0 minus, that would be 2 by 6 into 12. That means 4 volt. 2 by 6 into 12, that means 4 volt, right? So it will be equals to IL0 plus will be equals to VC0 plus. Okay. Now what will be the circuit at t equals to 0 plus? Circuit at t equals to 0 plus. This will be carried. Why we are interested in capacitor current? Sorry, why we are interested in inductor current? Because of the property of the inductor, right? So at circuit at t equals to 0 plus, what will happen? Now this switch is open, so this 2 ohm is gone. This 2 ohm is gone now, right? So I have a 12 volt battery, this 4 ohm resistance, and a current source of 2 ampere, right? And we should not forget what is the value of inductance, that is 0.25 Henry. That we will write here, okay? And then we have a capacitor, right? And the capacitor is having a voltage of 4 volt, right? 4 volt, sorry, 4 volt. And what is the value of the capacitor? That is 0.1 farad. So this is the circuit at t equals to 0 plus. So what do they need to find? I of 0 plus and V of 0 plus. What is V? This is V. And this is I. This is I. So V of 0 plus is basically Vc of 0 plus, right? That is equals to 4 volt. And what is I of 0 plus? That is basically IL of 0 plus, that is equals to 2 ampere. So these are my first two answers, okay? 2 and 4, okay? Now what do I need to find? I need to find the differentiation of current. So tell me, how do I get the differentiation of current? From the inductor voltage, because VL is equals to L di by dt, right? L di by dt. So if I know the initial voltage across the inductor, then I can tell the differentiation of current, right? So since VL 0 plus will be equals to di IL 0 plus by dt, and IL is equals to I only, so that would be d I 0 plus by dt, right? L di by dt, sorry, L will also be there. So what is the value of VL at t equals to 0 plus? This value we need to find. VL at t equals to 0 plus. Okay, this current is 2 ampere. This voltage is 4 volt. So tell me what is the value of VL at t equals to 0 plus. From here if you start, this is 12 volt. Now this is having a drop of how much voltage? 8 volt. 12 volt, 8 volt. So here I am having 4 volt. Here also I am having 4 volt. So the drop across the inductor initially is 0 volt. Here VL 0 plus is 0 volt. Did you understand it or not? This is my circuit at t equals to 0 plus. I am having 2 ampere current. Because of 2 ampere current, the resistance is having 8 volt voltage drop. 12 here and 8 here. That means 4 volt here. And because of the capacitor, 4 volt here. Because the capacitor will not change its current, voltage. Sorry. So 4 volt here, 4 volt here. That means 0 volt. So basically my VL 0 plus is 0 volt. Right? So by equation 1 and 2. What do I get? DIL 0 plus by dt is equals to 0 ampere per second, because it is current by time. So this is my third answer. Now what do I need? I need dV naught by dt. I need dV by dt. That means I need dVc by dt. How do I get dVc by dt? IC is equals to C dVc by dt. Right? So I need the capacitor current. Then I can tell the value of dV by dt. So now what do I know? IC 0 plus would be equals to C dVc 0 plus by dt, or it would be equals to C dV naught by dt. Here what is the value of? Here I just need to find IC 0 plus. Tell me what is the value of IC 0 plus? Is it 0? IC 0 plus is 0? No, 2 ampere only, right? The same 2 ampere current is flowing here. So IC 0 plus is 2 ampere only, right? The current through the capacitor, that is 2 ampere. That is 2 ampere, right? And why is it 2 not minus 2? Because what is VC? VC is from plus to minus, and the current is flowing also from plus to minus. If the current was flowing like this, I would have used a minus sign. But the current is flowing in the same direction. Let's just assume this is a capacitor. If the current is flowing in this direction, how the voltage will be developed? Like this, right? And this is over VC as well, or V as well, right? So the current is flowing in the same direction, in the direction where the voltage is developed. So that's why it is plus. We will see the example where we will take negative as well. Okay. So 2 is equals to, what is the value of C? C is 0.1 dV naught plus by dt. So from here you will get dV 0 plus by dt is equals to 20 volt per second. Okay. So this is the second thing. Now at infinity you need to know, at infinity what will happen? Now what is the thing that you know? I of infinity, V of infinity. So circuit at t equals to infinity. Is there a 12 volt battery is there? 12 volt battery is there. This will be shorted. This will be open circuited. This is already gone. So basically 12 volt battery is there. This is 4 ohm resistance. This is V and this is VL. Here this will be your I current and this will be your V, right? This is your I current and this will be your V. What do I need to find? I of infinity and V of infinity, I guess. Yeah. So tell me what is the value of I of infinity? That is 0 ampere. What is the value of V of infinity? That is 12 volt. That's it. This is my final answer. Okay. This question was a bit easy. Let me just check my answers. Yeah, all correct. So this was the question. How did we solve it? We just needed to relate the equations. That's it. We just needed to relate the equation, nothing else. Okay, I just know that how I get the differentiation of current by the inductor voltage. How do I get the differentiation of voltage by the capacitor current? And at t equals to 0, at t equals to infinity, we can directly write. So that's how we need to relate the expression. Now this is a very good question. This dVr naught by dt, this will be very interesting. I want you to solve it for only for this thing. Okay, otherwise this question is very easy. I just want you to solve, you guys to solve for this thing. Okay, now tell me what is the condition for t less than 0. For t less than 0, because here this is there for minus infinity to infinity, and this is there for t greater than 0 only. So minus infinity to 0, this will be in action, right? For t less than 0, this is not there, only this is there. So circuit for t less than 0. For t less than 0, steady state would have been reached. So basically circuit at t equals to 0 minus. Okay, this will be open circuited. So this is a resistance R. For this is not there for t at t equals to 0 minus, this is not there. This capacitor will be open circuited. This 12 volt battery is there. And what will happen to inductor? Inductor will be shorted, right? Inductor will be shorted. This is IL and this is VC. We are interested in only two things, VC 0 minus and IL 0 minus. Tell me what is the value of IL 0 minus? This is 4 and this is 2. Will there be any current? Because this is open circuited, so 12 volt battery will not induce any current, because this is just a open circuited. This is just a loop with no voltage source. So IL 0 minus is 0 ampere. And now this is, if this voltage is 0, this voltage is also 0. So if this voltage is 0, let's just assume this voltage is 0. So this voltage is also 0. So what is VC 0 minus? This is 0, this is 12. So this will be minus 12. That would be equals to VC 0 plus IL 0 plus. Okay. Now what I will do? I will make the circuit at t equals to, what about VR 0? This is VR. What is VR? This is VR. Okay. VR 0 minus. What is VR 0 minus? That is 0 volt. But that will not be equals to VR 0 plus, right? You can't write VR 0 plus will also be equals to 0, because this is a resistor. In resistor, there is no property that the voltage cannot change instantaneously. Voltage can surely change instantaneously. Okay. So VR 0 minus will not be equals to VR 0 plus. Okay. Now we will make the circuit at t equals to 0 plus. So this 3 ampere current source will be there. Well and good. 3 ampere current source is there. 2 ohm, 4 ohm. Okay. Across 2 ohm we are having VR, and then here we have 4 ohm. We have a capacitor and then a battery and inductor. This is having an initial current of how much? 0 ampere actually. Here we are having 0 ampere, but never forget the value. Value of inductance is 0.6 Henry, because there is an inductor connected as well. The capacitor is having initial voltage of minus 12. Like this is our VC, and here I am having minus 12 voltage. And what is the value of capacitor? That also you need not forget. That is 1 by 2 farad. Where do I write it? 1 by 2 farad. Okay. And what is the value of battery? That is 20 volt, and this is 4 ohm. Okay. So basically here, you know, one thing I would suggest you all, whenever you are solving this kind of problem, always give voltage to every component. Like, you know, the voltage across the resistance 2 ohm VR, across 3 ampere current source, that is also VR. Across this capacitor, that is VC. Across this inductor, that is 12 plus VC. Do you know the voltage across this? Yeah, it is VR minus VC plus 20. Right? This is VR minus VC plus 20. That is this voltage. Okay. Or I can give the value that I will give later on. Okay. So for solving the problem in a better way, always give some value. Let's just assume I am giving it V0 voltage. Okay. So at lower I can write. Okay, or later on I will write it whenever I need it. Okay. So what is IL0 plus, what is VC0 plus, and what is VR0 plus? So let's find out. So what is my IL? This is my IL. What is my IL0 plus? IL0 plus is 0 ampere. Okay, well and good. What is my VC0 plus? That is minus 12 volt. Well and good. What is my VR0 plus? That I need to calculate. Okay. So how will I calculate? Here is it 20 volt or 12 volt? 20 volt. So if it is 20, oh sorry. If this is 20 volt, VC0 minus would be minus 20 volt only, no? Okay. This is minus 20 volt. Okay. This is minus 20. This will also be minus 20. Minus 20. Will be minus 20. Now tell me one thing. If this is 0, this will be 20, this will be minus 20. So this potential will also be 0, right? This potential is 0, this potential is 20, this potential is 20 minus 20, that means 0 volt. So this 3 ampere current is getting divided into 2 and 4 ohm. One end of 2 ohm is connected to 3 ampere current source, one end of 4 ohm is connected to 3 ampere current source. One end of 4 ohm is connected to 0 volt, the other end of 4 ohm is connected, 2 ohm is connected to ground. That means 0 volt. So basically this is the condition here at t equals to 0, that a 3 ampere current source is there. One end of 2 ohm is connected to 3 ampere current source. 2 ohm is connected to 3 ampere current source. Other end is connected to ground. One end of 4 ohm is connected to 3 ampere current source, and the other end is at ground only, 0 volt, because this is 0, this is 20, this is minus 20. So other end is at 0. Now you need to find the value of VR. So tell me VR0 plus actually. So what will be the value of VR0 plus? 4 by 6 into 3. That means 2 volt. Are you getting my point? Just divide the current in inverse proportion. So 4 by 6 into 3. Okay, sorry. This is the current actually. So first I will divide the current. 4 by 6 into 3, and then I will multiply it with the resistance. So that means it will be 4 volt, right? VR0 plus is 0, they are saying. It is not 4 volt. Why is it so? In the answer it is shown 0. Let me check it. Yeah, 4 volt is correct. The given answer is wrong actually. Yeah, 4 volt is correct. Okay. So basically this, or you can say that 4 and 2 are in parallel. So 4 by 6 into 3. 4 by 6, that will be the equivalent resistance into 3. What I am doing actually? 2 into 4. 8 by 6 into 3. So that will be 4 volt. So basically VR value will be 4 volt. Okay. First I divide the current and then I just multiply the resistance. So VR0 plus is 4 volt. So these are the first 3 answers that I was looking for. Okay. Now moving on to the next thing. I need to find the differentiations. Okay. So first is DIL by dt. So how will I get DIL by dt? What I know, that VL0 plus is equals to L DIL 0 plus by dt. DIL 0 plus by dt. Now tell me what is the value of VL0 plus? Here, what is the value of VL0 plus? What is my VL? This is my VL. Tell me what is the value of VL0 plus? VL0 plus, the same voltage here, the same voltage of this, that is 0 only. The same voltage, VL0 plus is this voltage, this is the same as this voltage. So 0 20 minus 20, 0 volt. That means here VL0 plus is 0 volt. That means DIL0 plus by dt is 0 ampere per second. Well and good. Let's move on to the other thing. You know dVc naught by dt. dVc by dt. How will you get? By the capacitor current. So IC0 plus would be C dVc0 plus by dt. In both of the example, this differentiation of current is 0, but it's not necessary that it will always be 0. Okay, by chance it is coming 0, so don't mug up anything that it will always be 0. Okay, so what is IC0 plus? What is IC? This will be IC, right? This will be IC. What is IC0 plus? Tell me. IC0 plus, how will you find? The current in 4 ohm resistance, whatever the current is coming in 4 ohm resistance, the same current is going that way, right? This will be IC0 plus only, right? Why so? Because here the current is going is 0 ampere. So whatever the current that is in 4 ohm, that same current will be going in the capacitor as well. So what current is, how much current is going in 4 ohm? So in 4 ohm it will be 2 by 6 into 3, right? In 4 ohm it will be 2 by 6 into 3. Here IC0 plus would be 2 by 6 into 3. That means 1 ampere, right? That means dVc naught by dt would be 1 ampere by C. What is the value of C? Value of capacitance is 1 by 2. So it would be 2 volt per second, right? Because value of capacitance is 1 by 2 farad. Okay, so this is the second answer. Let me just check it. Yeah, it is 2. Now the most important part comes is dVr plus by dt. Now how will you find it? Right, this is the task, because what will give me dVr, what will give me dVr by dt? VRT is IT into R. Now if I write dVRT by dt, that means I need dit by dt, and that I don't have, right? The differentiation of current in this, that I don't have. Are you getting my point? Right, so I need to find that. Okay, so let's solve it. Okay, I want you to solve on your own first. Okay, so we at least need 2 equations here, so I will separately draw the circuit. So basically here I have a 3 ampere current source, right? I can make it like this, right? Then I have a 2 ohm resistance, then I have a 4 ohm resistance, then I have a capacitor, then I have a 20 volt battery. This is the scene. 20 volt battery, this is the capacitor, it is having minus 20 volt with the value of 1 by 2 farad. This is the 4 ohm resistance, this is a 2 ohm resistance, this is my VR. I need to find the differentiation of this. Let's just call this potential as V naught. Okay, so what do I see here? VRT is equals to V naught T plus VCT, this is my VC, plus VCT plus 20 volt battery, right? Plus 20. VRT is equals to V naught T plus VCT plus 20. That means my dVr0 plus would be equals to dV naught 0 plus by dt plus dVc0 plus by dt, and this 20 volt differentiation of this will be 0. So my dVr0 plus by dt would be equals to dV naught 0 plus by dt plus what is the value of dVc0 plus by dt? dVc0 plus by dt, that is 2, right? This is the first equation. Now I need to know what is the value of dV naught plus by dt. Look, first what did I think? That I can simply write the current. What did I think? VRT is equals to IRT into dt. This doesn't work. IRT into R. This doesn't work because I don't know the differentiation of this. So this is gone. Now what I can do? I can think of potentials. So I thought of potentials. Now this is the main issue here. V naught, right? Now V naught I can write in terms of VR and VC. V0 I can write in terms of VR and VC and as constant voltage. So this is what I wrote here. So this is the first thing. Now I need to think of something else. So I have this 3 ampere current source as well. So this 3 ampere current is equals to VR by 2 plus V0 by 4. Are you getting this point or not? 3 is equals to VR by 2 plus V0 by 4. So if I differentiate it, what I will get? 0 is equals to dVR 0 by dt into 1 by 2 plus 1 by 4 into dV0 0 plus by dt. So here what is the relation that I am getting? Like I need to find the value of dV0 0 plus by dt, that is equals to minus 2 dVR 0 plus by dt. This is equation 2. Okay, this thing, this was the important thing. Now by using equation 1 and 2, right, that's why I took this problem, because this was very interesting, right? Now I can put it 2 here, this will be 3, so 2 by 3 answer I will get. So dVR 0 plus by dt will be 2 by 3 volt per second. Well and good. So this is my third answer. Okay, this is my third answer. Now at infinity they are asking, what will be the value of IL infinity? IL infinity, the inductor will be shorted, capacitor will be open circuited, right? So what will be IL infinity? IL infinity will simply be 2 by 6 into 3 at t goes to infinity. Okay, I will not draw the circuit. IL infinity, the capacitor is open circuited, inductor is shorted. So 2 by 6 into 3, that means 1 ampere. What about VC infinity? VC infinity they are asking. That means this will be shorted only. The inductor will be shorted only. So this 0 will also come here. This will be 0. Again VC infinity will be minus 20. Right? VC infinity will be minus 20. How minus infinity you have understood now? This will be shorted. So this is 0. This is also 0. So here I have 20 and here I have 0. So VC infinity will be minus 20. Right? That will be minus 20 only. And what about VR infinity? VR infinity will simply be the current in this 2 ohm resistance into the resistance. So 4 by 6 into 3 into 2. 4 by 6 into 3 into 2. That means 4 volt. Right? 4 volt. So this is the final answer. These are my final answer. So I hope you have understood how to find the initial and final condition. Okay. So these were very good 2 examples. First we needed to know what is the circuit at t equals to 0 plus. For that we solved the circuit at t equals to 0 minus. So we got to know the circuit at t equals to 0 plus. So after finding the circuit at t equals to 0 plus, we wrote down these equations. From there we got to know the values. Okay. So if I need the differentiation of inductor current, that means I need the inductor voltage. If I need the differentiation of capacitor current, that means I need the capacitor voltage. Sorry, capacitor current. If I need the differentiation of resistor current, that means I need to think, right? Because there is no certain way, so I thought of it. Then I found the values at infinity. So at infinity, by simply making the circuit, you can find the values at infinity. Okay, so this was the complete question. Now what we will see? We will see sourced series RLC circuit. So what is happening? There can be initial conditions, like inductor can have I0 voltage, capacitor can have V0 voltage, but there is a source. So because of this source, we will have some steady state values. So tell me one thing. What will be VC infinity? What will be VC infinity? At steady state, the inductor will be short circuited and capacitor will be open circuited. So VC infinity will be Vs. What will be VC 0? 0 plus. Initial voltage, now it is saying it is 0. So it is 0. It can be V0 as well. Nothing will change here. It can be V0 as well. Nothing will change here. This is the final expression. That's it. This is the final expression, that's it. The value at infinity, any parameter you are finding, the value at infinity plus response same as the source free response. Okay. What about IC infinity? What will be IC infinity? That will be 0 ampere. What is IC 0? Initially it is 0 only, right? Initially it is 0 only because inductor is not having any current. Now what about inductor? What will be VL infinity? At infinity, the inductor acts as short circuit, so it will be 0. What is VL? 0 plus. What is VL 0 plus? The capacitor acts as short circuit and the inductor acts as open circuit. So there is no initial current here. So VL 0 plus is Vs. How did I write it? VL 0 plus is Vs. How did I write it? What is the initial circuit? This is the initial circuit. This is the initial circuit. Capacitor is shorted. This is the initial. Here I have Vs. This is the current here is 0. So here this is my Vs. This will be Vs and this will be 0. So what is VL 0 plus? That is Vs only. Okay. I hope you are able to write it on your own now. What is IL 0 plus? That is 0 since the inductor is not having any initial current. And what is IL infinity? That is also 0 because at infinity capacitor will be open circuited. Right? So let's just assume you are writing the expression for VC infinity. Sorry, VCT. You are writing the expression for VCT. So if you forget this, the response will be the same as source free response. Because of this, you are having some VC infinity voltage. That is Vs. Right? And let's just assume you are writing the expression for ILT. For ILT, it will be the same as source free response. Why is it so? The response will be the same as source free response if you are writing for ILT. Why is it so? Because IL infinity is 0 ampere only. At steady state, you will have no current. So this expression will be 0 only. So it will be the same as source free response. So whenever there is source is given, you just need to think I will be writing as source free response only, just the infinity value I will add for whatever the expression they are asking. They are asking for voltage, so voltage at infinity. They are asking for current at infinity. They are asking for capacitor, then capacitor voltage at infinity, capacitor current at infinity. If they are asking for inductor, then inductor voltage and inductor current at infinity. Okay. What will be the roots for serial RLC? The roots will be the same as well. R by 2L and omega equals to 1 by root LC. Okay, omega naught equals to 1 by root LC. Roots are minus alpha plus minus root alpha square minus omega square, omega naught square. Okay, what is the case of underdamped response? Same thing is there, nothing different. Underdamped is alpha is greater than, sorry. Underdamped alpha is less than omega naught. Okay, so what will be my roots? My roots will be minus alpha plus minus j beta. So simply what will be my y of t? My y of t would be y of infinity plus e to the power minus alpha t cos c1 not j beta, alpha plus minus not j beta, we write it omega d. Actually you can write beta as well, but in the previous expression we write it as omega d, so I am writing omega d here. Okay, c1 cos omega dt plus c2 sin omega dt. Okay, this will be my yt. Okay, let's just write it for what? Critically damped. You should write it on your own now, right? For critically damped, what is the case? Alpha is equals to omega naught. What is the roots? What are the roots? Roots are minus alpha and minus alpha. What is the condition? Condition I forgot to write. That is alpha is equals to omega naught. Roots are minus alpha and alpha. What will be the equation? Y of t. That will be y of infinity plus e to the power minus, and not e to the power minus alpha t. It is c1 plus c2t e to the power minus alpha t. Okay. This is for critically damped. Third is for over damped. What is for over damped? Alpha is greater than omega naught. What are the roots? Roots are lambda 1 and lambda 2, right? What will be your yt? Y of infinity plus c1 e to the power lambda 1t plus c2 e to the power lambda 2t. Right? So this is the responses. Okay. Now for sourced parallel RLC circuits, what will happen? Now I am giving a source of current source. It can be a voltage source. Let's just assume the circuit is something like this. It is the same case of parallel RLC. Why is it so? Because you can convert the voltage source into current source. If you convert the voltage source into current source, it will be like this only. Okay. So every circuit you will see that will be a combination of series or parallel RLC circuit only. We will see the example, you will get to know. Okay. So response same as source free parallel RLC expression will have the steady state value. Just as steady state value will be there. So basically this will be our response. Okay. What will be my roots? Roots is going to be my alpha plus minus root alpha square minus omega naught square. What is the value of alpha? Alpha is 1 by 2RC. What is the value of omega? That is 1 by root LC. Right? Omega naught is 1 by root LC. In case of underdamped response, it will be the same, I guess. I can copy this page. Nothing different will be there, right? Underdamped response, yeah, everything will be the same. You can just copy this page, nothing else. Right? Because everything will be the same here. Yeah. For underdamped response, alpha is less than omega naught. This is the root. These are the roots. But just the alpha value is changed. Alpha value is 1 by 2RC. Omega naught is 1 by root LC. Now what we will do? We will see some examples. Okay. So there will be a bit of complex calculation there. Not that much of complex. You can solve it on your own. Okay. So a bit of complex calculation will be there. So what is happening? You need to write the expression for Vt. What is happening? The switch is being closed at t equals to 0. Sorry, the switch is being opened at t equals to 0. That means it was closed for t less than 0. So now I can directly write circuit at t equals to 0 minus. T equals to 0 minus. 2 ampere current source is there. 2 ampere current source is there. A resistance is there. Inductor will be shorted. Inductor will be shorted. And the capacitor will be open circuited. Right? Right? Well and good. This is your V. And let's just call this as IL. Okay. So I will be interested in IL 0 minus because this will be carried forward. So IL 0 minus will be 2 ampere will be completely flowing through this short circuit path. 2 ampere. What will be my V minus, V0 minus? Because this will also be carried forward. So that is 0 volt because this is a short circuit part. So that is 0 volt. Right? Well and good. Now what I will do? I will make circuit at t equals to 0 plus. Circuit at t equals to 0 plus. What will happen at t equals to 0 plus? Not for circuit at t equals to 0 plus, circuit for t greater than 0. I should write circuit for t greater than 0. This is an inductor and a capacitor is there. Inductor is 20 ohm, 10 Henry, 20 ohm, 10 Henry, and the capacitance value is 4 millifarad. This is my V. The initial voltage was 0 volt, right? 0 volt, and the current is 2 ampere. Current is 2 ampere here. Okay. First we need to find the value of damping. Then we will think of anything else. We need to find the Vt. First find the damping, because you don't need at t equals to 0 plus or t equals to 0 minus. You need the expression, time domain expression. So whatever that you know, you can write. IL of 0 plus. IL of 0 plus. You know that. What is IL of 0 plus? That is 2 ampere. What is V of 0 plus? That is equals to Vc of 0 plus actually. And that is equals to 0 volt. What else you know? VL of 0 plus. Tell me what is the value of VL of 0 plus. VL is this. I am calling this as VL. So VL of 0 plus is equals to V of 0 plus, that is equals to 0 volt only. Right? What else you can find? You can find VC of 0. You can find IC of 0 plus. Tell me what will be the value of IC of 0 plus. If this is short circuit, then this initially this 2 ampere current that will be completely flowing through here. IC of 0 plus is minus 2 ampere. Are you getting my point? If I am saying this is my IC, if this is my IC of 0 plus is minus 2 ampere. I don't know if it will be used or not, I just wrote it. Okay, you don't need to write it, I just wrote it. Okay, if I am saying this is my IC, so 2 ampere current will be initially flowing through the capacitor only. Why? Because this is a short circuit path. Okay, so I don't need to write it. First I need to find the value of, this is what, parallel RLC. Parallel RLC. First I will find the value of alpha, that is 1 by 2 RC. You need to remember it. That would be 1 by 2, R value is 20, C value is 4 milli, right? So it will be 80 milli. I need to check if I have solved it. I must have solved it, but not neatly. Is this the same? Let me solve it. $40 into 4 divided by 1000, 6.25. Yeah, alpha is 6.25. Okay, what about omega? That is omega naught, 1 upon root LC. That is 10 into 4 milli. Okay, root 1 upon 10 into 4 milli, that is coming out to be 5. Okay, I will just check once more. 10 by 2, yeah, 5. So here what is happening? Alpha is greater than omega naught. That means what are the roots? Roots are minus alpha plus minus root alpha square minus omega naught square. That means minus 5, not minus 5, not minus 5, minus 6.25 plus minus root 6.25 square minus 5 square. So basically your roots will be minus 10 and minus 2.5. Minus 10 and minus 2.5. Two different roots. Or here also you got to know alpha is greater than omega naught. So here also you got to know this is an overdamped system. Overdamped. Okay. And here as well you got to know this is an overdamped system. Right. So the roots are minus 10 and minus 2.5. So what do you need to find? You need to find VCT. Right. VT. So what will be the expression of VT? Since it is a parallel RLC with only initial condition, no source is there, because source is gone. For t greater than 0, source is gone. So no source is there now. This is the condition, right? So Vt would be C1 e to the power minus 10t, C1 e to the power minus 10t plus C2 e to the power minus 2.5t, right? Now you need to find the value of C1 and C2. Find C1 and C2. This is my task now, right? V of 0 plus, what is V of 0 plus? That is C1 plus C2. What is the value? V of 0 plus. V of 0 plus is 0 volt. That means C1 plus C2 is 0, not volt, 0. Now one more thing I can do. This is equation 1. Now first is the simple Vt, second is the differentiation of Vt, because if I put V of infinity, it will be 0. This expression will be 0, this expression will be 0. So you can't get any equation between C1 and C2, right? So second thing I can do is that I can calculate the differentiation, right? So now I know one thing, ICT would be equals to C dVCT by dt. dVCT by dt. So basically IC 0 plus would by C would be equals to dVC 0 plus by dt. What is the value of dVC 0 plus? That is minus 10 C1 minus 2.5 C2. Did you get to know how did I write it? Did you get to know how did I write it? I just simply differentiate it. C1 into minus 10 e to the power minus 10t plus C2 into minus 2.5 e to the power minus 2.5t. Put t equals to 0. This will be 1. This will be 1. So minus 10 C1 minus 2.5 C2. And now that value will be equals to something else. So this is how I wrote it. Okay. So I know IC at t equals to 0 plus, that is minus 2. If I am taking IC in this direction, then only V will be in this direction. Na? What I am saying, my current is flowing from up to down, then only my V will be positive. No? So I have to take IC in this direction. So IC 0 plus is minus 2 ampere. That's why I wrote it here, because somewhere it will be used. I knew it. I knew it. That's why I wrote it here. So it is minus 2. Minus 2 by what is the value of capacitor C? That is 4 milli. Minus 10 C1 minus 2.5 C2. So 500, it will be 500 around. Yes. Yeah, 500 is equals to 10 C1 plus 2.5 C2. Actually, a bit of complex calculation is there, but for placements they won't ask you this question, but in gate they can ask you the calculation as well. Okay. Now you have two equations. By solving 1 and 2, by solving equation 1 and 2, you get the value of C1 and C2, and C1 is equals to 66.66 you get, and C2 will surely be negative of this, minus 66.66. So basically what is your Vt? Your Vt is 6.66 e to the power minus 10t minus e to the power minus 2.5t. This is your graph. Okay, this is your expression. Now in the exam they can ask you what will be the value of Vt at t equals to 1 second. So for that you need to completely solve it. If they had asked you the graph, you know that it will start from 0, it will go to 0. It will start from 0, it will go to 0. And a slower response, right? And will it go negative ever? Like you don't really know. One thing you know, that it will start from 0, it will go to 0. You know this thing, that it will start from 0 and it will go to 0. Now you can think that Vt can go to negative or not. So you can check the value at t equals to 1 second. So let's just check the value at t equals to 1 second. So 66.60 it would be e to the power minus 10 e to the power minus 2.5. So 1 by e to the power 10, 1 by e to the power minus 2.5. This value is larger, so this value will be lower. this value is lower, so this value will be larger. So yeah, it will go negative actually. Okay, if you just calculate, this is nearly equals to 0, and what about 2.5? Yeah, so it will go negative actually. Okay, and I hope I have solved it correctly. C1 is this and C2 is this. Yeah, so it will actually go negative. So with time it will go negative. So the graph will not be looking like this VT graph, because I know VT value is going negative. So the graph will be different. It can go, I guess it can go like this. I can't really make it like, no one really can make it. No one really can make this graph. You need to have some tools from there. You can load this graph in MATLAB, but or any other tool. But if I want to make the graph on my own, will the value will always be negative? That I need to think. So if I think by the circuit, what is happening? What is happening in the circuit, that I can think that initially the 2 volt is there and 0 volt and 0 volt is there and 2 ampere current is there. Okay, and IC will charge the capacitor in the opposite direction. That means it will induce a negative voltage. Like 2 ampere current is flowing in this direction. That means it will induce a negative voltage. So the negative voltage, yeah, look, from here only I got to understood. If you have good circuit analysis, then you can understand. Like this 2 ampere is flowing in this direction. That means it is flowing in this direction. That means it will induce a negative voltage. So V value is getting negative, right? It will induce a negative voltage. So that will reduce the current. So slowly the current will be reducing. Slowly the current will be reducing. Eventually the current will go down to 0. So always V value is negative. 2 ampere current is flowing in the capacitor like this. That means it is inducing the voltage in negative direction, and the same voltage is going across the inductor. So if the same voltage is going across the inductor, that is reducing this 2 ampere current. So slowly the 2 ampere current is going down to 0, and the voltage is also going down to 0. From negative it will increase, then when the current goes down to 0, the voltage also goes down to 0. Okay, so this is what is happening. So the graph will be something like this. It will always be negative. Okay, and what will be the maximum value of V naught T, that can I find? How I can find? Minus 10 e to the power minus 10 t. I am just differentiating it, e to the power minus 2.5 t. Okay, and put equals to 0. Then if I put equals to 0, this will be 4 e to the power minus 10 t. It would be equals to e to the power minus 2.5 t. So I can find the value of t from there, then I can find the maximum value as well. So you can find the maximum value as well. That value will be negative as well, but I don't need to find that value. Okay, so you can find that negative value as well. Okay, so this is the graph for Vt. Okay, now let's move on to the next question. This question I want you to solve on your own. Then there is one more question. Okay, this calculation, this has a very large calculation. This question you can solve on your own. Okay, yeah, so I just solved the previous problem. Actually the maximum value we are getting is, that is minus 31.5. okay, and the time is, what is the time? Time is 0.187, I guess. I don't actually remember the time. Okay, this was the time as far as I remember. Okay, so how did I solve it? Actually I just did dvt by dt is equals to 0. Then from here you will get time t max, and put the time t in this equation, you will get the Vt max. Then you can get the Vt max. Just I solved this equation, nothing else. Okay, so this value you get, and the maximum value is get is minus 31.5. So these kind of question they can ask, what is the maximum value? This is the actual minimum value. What is the minimum value of V can go? That is minus 31.5. This is the minimum value. Okay, so you have to draw the waveform of IT now. Okay, so this is a series RLC circuit. So the switch is being closed at t equals to 0. So just tell me what will be, the switch is being closed at t equals to 0. So at t equals to 0 plus, this will have 5 voltage. The capacitor will have 5 voltage. This is 3 ohm. This will have 0 current, right? This is 1 Henry, don't forget. This is 5 volt and this is 0.5 farad. Okay, I will call this as VL. If I am calling this as VL, that means my IL will be something like this. If I am calling this as IC, this is my IC, then this will be my VC, right? I need to find IT. So here IT is equals to ILT, but negative of minus ICT. Just expression I am writing. I don't know if I will be using it or not. Just to give you a brief overview. Okay, what will be my IL0 plus? That will be equals to my IC0 plus. That is 0 ampere, right? Because initially it is having no current. What is my VC0 plus? That is 5 volt. What is my VL0 plus? This time it is 5 volt as well. VL0 plus is 5 volt, right? VL0 plus is 5 volt. Now this 5 volt will induce some current in the inductor, right? And the capacitor will discharge and the inductor will charge. So basically the current will be positive. I'm just doing the analysis. Are you getting my point? What I'm saying? We have seen a lot of RLC circuit. You can do the analysis. This 5 volt is coming across the inductor. This 5 volt is coming across the inductor. That means it will induce the current in from up to down. That means this current will be going out of the capacitor and getting into the inductor. That means inductor will charge and capacitor will discharge. Getting my point? Right? So this is what is happening here. Okay. So we don't need to do all this. I just need to draw the waveform for IT. Just the waveform. Okay. Just the waveform. So tell me, what is the alpha here first? Alpha is R by 2L because it is series RLC. It is R by 2L. So that is 3 by 2, 1.5. What is the value of omega naught? That is 1 by root LC. That will be 1 by root LC. So root 2. Root 2 is 1.414. So here what is happening? Alpha is greater than omega naught. That means again it is overdamped. So basically overdamped response will be there. I of 0 plus. I of 0 plus was 0 ampere. I of 0 plus was 0 ampere. Since there is no source, what will be I of infinity? That will also be 0 ampere. Current initially was 0. At steady state as well, it will be 0. Because at steady state, what will happen? The capacitor will be open circuited. So the current will be 0 only. So from 0 to 0, it will go. But it will be positive or negative. Now we know that the response is overdamped. Now I can draw the graph. The response is overdamped. But the current will be always positive or negative? The current will be always positive. Why so? Just only I explained that this 5 volt will come across the inductor, and if this 5 volt is coming across the inductor, that means it will induce the current in this direction. This 5 volt will come here and it will induce the current in this direction. So the current will be positive. Okay. Current will always be positive and it will go like this. So we just need to make the graph. Okay. The current will go like this. It won't stabilize so early. It will be a damp response. So it will be going there slowly. Okay. Okay. There will be some maximum value and all these things you don't need to find. Just you need to tell the nature of graph. The graph of nature of graph will be something like this only. Are you getting my point or not? It will increase, get some maximum value and go downward. Okay, but there will be no oscillations, that's for sure. Okay, now the last problem, this is the problem. You need to find the expression of Vt and It and then draw the waveforms. So now what is the condition? For t less than 0, for t less than 0, circuit at t 0 minus, circuit at t equals to 0 minus, steady state would be reached, steady state would be reached, right? Steady state would have been reached. So inductor will be replaced with the short circuit. R value is given is 5 ohm. Okay, inductor will be replaced as short circuit. This will be open circuited. This will be 1 ohm. Okay, so what is V of 0 minus? That is 1 by 6 into 24. That is 4 volt. What will be I of 0 minus? That will be 24 by 6. That means 4 ampere. Why I am interested in these two? Because it will be conserved. Circuit at t equals to 0 plus. What will happen? Circuit for t greater than 0 I should make. Circuit for t greater than 0. What will happen? This will be gone. This resistance will be gone. This 1 ohm resistance will be gone because the switch is being opened. This 1 ohm resistance will be gone. This is a 12 volt battery. This is a resistance R, an inductor and a capacitor. Sourced series RLC circuit it is now, right? R is 5 ohm, L is 1 Henry and 0.25. L is 1 Henry and it is 0.25 farad. Initial voltage is 4 volt. The current is also 4 ampere. 4 volt, it is 4 ampere. This current we are calling as I and this voltage we are calling as V. This voltage is over V. Okay. So now talking about Vt. First I will talk about Vt. There is this one thing here that will be interesting, that it is sourced series RLC. Talking about Vt. Before talking about Vt or anything, okay, first find the damping. What is alpha? Alpha is R by 12. 5 by 2, that is 2.5. What is omega naught? That is 1 by root LC. 1 by root LC. 1 into 0.25. That is 2. That means our alpha is greater than omega naught. Again it is overdamped. Why I am taking overdamped example? Because the calculation is a bit simpler. In case of underdamped, the calculation will be very, very difficult. Because sinusoid will be there and you have to differentiate, it will be a big expression. Right? In case of critically damped, the calculation will be a bit easier. In case of overdamped as well, the calculation is a bit easier. But in case of underdamped, the calculation will be very tough. Right? What will be the roots? Roots will be minus 2.5 plus minus alpha square minus omega naught square. 2.5 square minus 2 square. Okay. By solving this, you will get the roots as, first I will just take it downward. Take it downward. Roots you will get as, have I solved it? and this is 6.25, 1.25, minus 1.5, minus 1 and minus 4, minus 1 and minus 4. So minus 4 and minus 1 you will get. Now talking about Vt. So what you will write? So it is na. So V infinity C1 e to the power minus 4t plus C2 e to the power minus 1t. What is the value of Vt at t goes to infinity? That will be 12 volt, right? Here V infinity. What will be V infinity? At infinity, the capacitor will be open circuited and the inductor will be shorted. So 12 volt will be coming there. So it will be 12 volt, right? So Vt will be 12 volt plus C1 e to the power minus 4t plus C2 e to the power minus t, right? Now find C1, C2. Find C1 and C2, right? What is the value at t equals to 0 plus? V of 0 plus. That will be 12 plus C1 plus C2. What is the value at t equals to 0 plus? That is 4 volt. 4 volt, right? At t equals to 0 plus. It was 4 volt. Yeah, 4 volt. This is 4 volt. So C1 plus C2 is minus 8. This is equation 1. Second thing, what you can do? You can differentiate. So one thing you know that ICT, what is ICT? ICT will be this only. ICT, right? So ICT would be equals to C dVt by dt. C dVt by dt, right? So IC0 plus by C would be equals to differentiation of V at 0 plus, right? And differentiation of V at 0 plus would be minus 4C1 minus C2. What is IC at t equals to 0 plus? 4 ampere current is flowing, right? 4 ampere current. I of 0 minus, wait. Yeah. I of 0 minus will be equals to I of 0 plus. So IC at t equals to 0 plus will be 4 ampere only, right? Here IC at t equals to 0 plus will be 4 ampere only, because the current in the inductor and capacitor is the same. The current in the inductor and the capacitor is the same, because and inductor is holding its current and the same current will be flowing through the capacitor. So IC0 plus is 4 ampere. What is the value of capacitance? That is 0.25. So 4 by 0.25 minus 4C1 minus C2. From here you will get 4C1 plus C2 is equals to minus 16, right? This is the equation 2. These are the equation only I am getting. C1 plus C2 is equals to 4. C1 plus C2 is equals to, wait. 24 it is, battery is 24. Oh. It is 24. Why I am doing these mistakes? It is 24. Battery is 24 volt. Okay. This is 24 volt. So here I will have 24. 24 volt. This will be 24. This will be also 24. Here again I will get minus 20. Right? Silly mistake was there. I just reduced it to half. I don't know why. 24 it is there. Okay. 24. So these two equations are there. From there you can get the value of C1 and C2. So C1 you are getting 4 by 3. C2 you are getting minus 64 by 3. 4 by 3 and minus 64 by 3. Basically minus 60 by 3. Yeah. From here you get C1 as 4 by 3. Just a lot of calculation is there, right? Like this will be the last step actually. And C2 you will get minus 64 by 3. What is your Vt? Vt will be 24 minus, 24 plus 4 by 3 e to the power minus 40 minus 64 by 3 e to the power minus t. This is my Vt. Now what do I need to find? I need to find It. So one thing I know here is that my It is equals to ICT, right? And that is equals to C dVc by dt. Basically, if I just, what do I do? It would be equals to, what is the value of C? That is 0.25. And just differentiate it. So it will be minus 16 by 3 e to the power minus 40 plus 64 by 3 e to the power minus t, right? So it would be 1 by 4, it would be minus 4 by 3. Yeah, this is what we are getting, minus 4 by 3 e to the power minus 40, and from here I will get 1 by 4, 16 by 3 plus 16 by 3 e to the power minus t. From here I get the value of It. Here I of infinity is 0, right? You can check as well. Here I of infinity is 0. I of infinity, what is the value of I of infinity? Or how would you write it? If you don't know the value of Vt, how would you write it? Or how would you write it? It would be I of infinity plus C1 e to the power minus 40 plus C2 e to the power minus t, right? Here I of infinity, what will be the value of I of infinity? At steady state, the capacitor will be open circuited, so the current would be 0. And now your task would have been to find C1 and C2, right? So now your task would have been find C1 and C2. So if you find C1 and C2, this would you get. C1 you would get as minus 4 by 3 and C2 you would get as 16 by 3. Okay. So these two values you would have got, and your It would have been this minus 4 by 3 e to the power minus 40 plus 16 by 3 e to the power minus t. Well and good, but this would take a lot of calculation. Since we have already found Vt, I prefer to find It like this. So this is the complete RLC circuit analysis. I hope you have understood. So what did we actually learn here? The main concept was of damping. That was the most important concept here. Because in damping we see three cases: underdamped, overdamped and critically damped. These three cases we have seen. Now the case that is left is undamped, like continuous oscillation, and that we will see in LC oscillator part. In LC oscillator we will see undamped oscillations. So I hope you have understood the complete lecture. It took us around 2.5 hours to study the complete RLC circuit. So this was the time domain analysis of RLC circuit. Frequency domain analysis of RLC circuit we will study in resonance, right? So in resonance we will study that, but this is the time domain analysis, and I hope you have understood it completely. So there are underdamped response, undamped response. How does the underdamped response look like? How does the undamped response look like? How does the overdamped response look like? What is the condition? Alpha is greater than omega naught, alpha is less than omega naught, alpha is equals to omega naught, right? And then what is the value of alpha in case of series RLC, in case of parallel RLC? And what is underdamped response? In underdamped response, we are having some oscillations, and in critically damped, we are having no oscillation and faster response. In overdamped, what we are having? We are having no oscillations but a slower response, right? So these things we have studied. And in case of series RLC, alpha is R by 2L. In case of parallel RLC, alpha is 1 by 2RC, right? And what is the value of omega naught? That is 1 by root LC. And the conditions for underdamped, it is alpha is less than omega naught. For critically damped, it is alpha is equals to omega naught. For overdamped, it is alpha greater than omega naught. So these things we have studied, and I hope you have enjoyed the lectures. So if you liked the lecture, please do share it with your friends. Okay. In the next lecture, we will study LC oscillator. Then we will solve 2 or 3 assignments. 2 to 3 assignments at least we will solve. Okay. That will be mixed of RL, RLC, RC, LC, everything will be mixed, right? So I hope you have enjoyed the complete transient lecture. So I meet you in the next video with LC oscillators. Okay.